Hello and welcome. I am Leung. Today I'm going to show you how to solve this particular linear equation here this particular higher order differential equation. So as you can see here, we have x cubed y triple prime plus 2y double prime plus x y prime minus y is equal to 15 cosine of 2 ln x, where y of 1 is equal to 2, y prime 1 is equal to negative 3, and y double prime of 1 is equal to 0. So using Leung, we let y is equal to x raised to the power of m, and then we just solve its derivatives to the third derivative, and then substitute it to the complementary solution, where this expression is equal to 0, and then we factor out x raised to the power of m. When we factor it out, we know assuming that x is not equal to 0, that the expression is not equal to 0. So we leave that out, and then we solve for the roots of the polynomial. And then after that, we factor it, and then solve for the value of m. So we have here m is equal to positive negative I, or m is equal to 1. So we have this complementary solution here, where y of c is equal to c sub 1 x raised to the power of I plus c sub 2 x raised to the power of I and plus c sub 3 times x. So we replace x raised to the power of m to e raised to the power of m ln x. And using Euler-Cauchy's equation, the identity in Euler-Cauchy, we have y sub c is equal to c sub 1 cosine of ln x plus c sub 2 sine of ln x plus c sub 3 x. Now, to solve for the particular solution, we have this. So we list the solution basis of the complementary solution, which is we express it as y sub b. So we have y sub b sub 1 is equal to cosine of ln of x, so the natural log of x. Y sub b sub 2 is equal to sine of ln x. Y sub b sub 3 is equal to x. And then we take the Wronskian matrix of that. We solve for the Wronskian matrix. As you can see here, we have cosine ln of x, sine of ln x, and x, and then we just take the first derivative and the second derivative of those, and then solve it. We have 2 over x squared. And then we also solve for the determinants of the Wronskian. So we have here w sub 1 is equal to negative cosine ln x plus sine ln x. W sub 2 is equal to negative cosine ln x minus sine ln of x, and cosine and w sub 3 is equal to 1 over x. And then the following step is to divide this equation divided by the largest coefficient, which is x raised to the power of 3. So we divide that. We have this. We divide it by x raised to the power of 3. We have this expression here, and this lets us use this expression here, 15 cosine of 2 ln x over x cubed, as our function, and we just solve for u sub 1, u sub 2, and u sub 3. So as you can see here, u sub 1 is just f of x times w sub 1 over w dx. So we have that, and then it just follows through to u sub 2 and u sub 3. After that, solving the u sub 1, u sub 2, and u sub 3, we now have a value of y sub b, which is this huge expression, and then we simplify it, and we have y sub b is equal to cosine of 2 ln x minus 2 sine 2 ln x. So that just shows you that when something is complicated, it can be broken down into simpler things. So we now have the value for y. We now have y. So y is equal to c sub 3x plus c sub 1 cosine of ln x plus c sub 2 sine ln x plus cosine 2 ln x minus 2 sine 2 ln of x. Okay, but we are not done yet. Although this is the solution, it is we still have to solve for these particular conditions in order to solve our final answer. So in order for us to do that, we need to solve for the first derivative of this expression and the second derivative of this expression. So I have already done that. This is the first derivative and this is the second derivative. Now what we are going to do is going to use y of 1 is equal to 2 on to this expression here of y. We substitute it and we have c1 plus c3 plus 1 is equal to 2. We have that equation. We use y prime of 1 is equal to negative 3 to this equation of y prime. We have this equation c sub 2 plus c sub 3 minus 4 is equal to negative 3. And then likewise, we use y double prime of 1 is equal to 0 to this expression of y double prime, and we have this equation here, negative c1 minus c2 is equal to 0. Solve these three system of equations and we have these values. We achieve these values. C sub 1 is equal to 0, C sub 2 is equal to 0, and C sub 3 is equal to 1. And then with that, we substitute it to this. We substitute it to that. And then we have finally y of x is equal to x plus cosine 2 ln x minus 2 sine 2 ln x. And that's how you solve it.